All right, let's dive into something pretty radical today. What if we started thinking about agriculture not as some kind of factory, but as a biological operating system? We're going to get into the core philosophy, the kernel, if you will, that could power a whole new way of growing. So, let's boot it up. So, here's the starting point. The big idea is that our current food system is basically corrupted software. It's buggy, it's old, and it's running on a code of just taking and wasting. It's a glitch in the system that's causing these massive crashes all over the place.
And that's the real question, isn't it? Instead of just trying to patch up the old, broken code, what if we could just do a full reboot? What if we could install a totally new system with a regenerative logic right at its heart?
Okay, so to really get why this new OS is so powerful, we have to run a quick diagnostic on the old one. We got to see exactly where that code is broken. This right here shows you the huge shift in logic. On the left, you've got the industrial model, and it's just a straight line, a conveyor belt. You pull resources out of the ground, you rent fertility by buying a bag of fertilizer, you use it, and you create a bunch of waste. But on the right, the biological model is a circle. It's all about regenerating, baking fertility for the long haul, and closing that loop so that waste isn't waste anymore. It's a resource. Every great operating system is built on a core idea, a philosophy. And for this one, it's all about being radically connected. So let's take a look at the manifesto that's written into every line of this new code. That's the name of the manifesto. And wow, is that a direct challenge to this idea that we humans are somehow separate from nature, or worse, in control of it? It's basically calling out what it calls the illusion of autonomy, this belief that we can do just fine all by ourselves. So, the key takeaway here is this. Our survival is completely 100% tied to the health of the microscopic world under our feet. It's arguing for a huge shift away from trying to dominate nature with a spray nozzle and moving toward a culture of care, where we actually work with that incredibly complex, invisible web of life in the soil. Now, this is where that philosophy starts to get really, really practical. See, this new OS doesn't just change how we think about biology, it totally rewrites the rules of economics on the farm. This quote just nails the economic revolution happening here. You stop being a renter, constantly paying for stuff that's gone after one season. Instead, you become a banker. You're creating and growing biological assets that actually compound and get more valuable over time. This slide just lays it out so clearly. On the left, buying microbes is like buying printer ink. It's an expense, you use it, and it's gone. But on the right, when you cultivate your own biology, it becomes an appreciating asset. You go from being a consumer to a creator of value, building real, inheritable wealth right there in your soil. And this leads to this really powerful new way to measure things called biological equity. Think about it this way. You're not just saving money by not buying synthetic fertilizer. No, you are actively creating new measurable value right there on your farm. It's like you're printing your own currency, and it's backed by biology. And check this out. It's not some vague, fuzzy idea. It's actual math. The formula for biological equity is pretty simple. You take the amount of biofertilizer you made and multiply that by what you would have paid for the synthetic stuff you didn't have to buy. Then you just subtract the tiny cost of making it yourself. And that number you get, that's real, quantifiable wealth that you literally created from things most people would call waste. Let's make this real. According to the source material, just one 190-liter batch of a homemade biofertilizer made from things like, urine, can generate over 3,500 pounds in biological equity. That right there is the power of this economic engine. It's a total game changer. So you might be wondering, okay, that's cool, but how can one system work everywhere, from a little balcony garden to a huge farm? Well, the answer is this really elegant idea borrowed straight from software design, the difference between a wireframe and a graphical user interface. So, the wireframe, that's the deep code of the operating system. It's the set of rules that are non-negotiable. These are the laws of nature that work the same way everywhere on the planet. Photosynthesis is photosynthesis, whether you're in Peru or Portugal. That's the universal backend. And then you have the GUI, the graphical user interface. This is what you, the user, actually interact with. It's the local, flexible front end. It's how you apply those universal laws, using whatever is cheap, abundant, and right there in your backyard. And that's what makes the whole system so ridiculously adaptable. And here's the perfect example of a GUI shift. The system that inspired this, Korean natural farming, is based on a rice culture GUI. Makes total sense, rice is the staple there. But the Western adaptation, HBNF, just swaps out the interface. It installs a potato culture GUI, using local potato waste to run the exact same biological wireframe. And by doing that, you slash your costs and your carbon footprint. It's brilliant. All right, last but not least, let's look at the execution, the philosophy of how things actually get done in this OS. And this is a major leap that really separates it from a lot of other organic approaches. It's this concept called metabolic precision. It's basically the difference between random rotting, just piling up compost and kind of hoping for the best, and acting like a biochemical surgeon. This system uses very specific biological tools, like enzymes, to get very specific results from plants. So instead of that slow, uncontrolled process of just letting things decay, this method uses something called enzymatic hydrolysis. The best way to think about it is like using a specific key, that's the enzyme, to perfectly unzip a complex nutrient and make it instantly available. It's precise, it's fast, and it is unbelievably efficient. So there you have it. Those are the 5 core principles of the kernel. It's a philosophy of interdependence, an economy of assets that actually grow, a design that's both universal and totally local, and an execution that's all about targeted, precise action. Put them all together and you've got the code for a whole new biological operating system. We're going to end on this powerful thought. This system isn't just about growing food for this season. It's about cultivating a legacy, a biological and a community legacy that actually gets more valuable and wiser over generations. So the question it really leaves us with is, are we going to keep renting our future? Are we finally ready to start banking it?